Hi everyone, and welcome to our video on quantifying risk using a 2x2 table.
2x2 tables can be used for a variety of purposes. In this video, we will be explaining how 2x2 tables can be used to quantify risk. This allows us to determine how different risk factors can cause disease. Suppose you want to determine how diet and exercise affects the risk of diabetes, or how female sex increases the risk of developing Alzheimer's. Quantifying risk using a 2x2 table can be used to show the relationships between these variables.
To use a 2x2 table, there are only a couple pieces of information you will need. First, you must know what the risk factor is that pertains to a given disease or condition, and how many subjects do and do not have the risk factor. Second, you must have the numbers of subjects with and without the disease.
Here's a picture of the 2x2 table. 2x2 tables can be used to quantify a relative risk of a disease given a specific exposure. The two columns are designated disease and no disease. The two rows are designated exposure and no exposure. Box A represents the individuals who do have both the disease and the exposure. Box B represents individuals with no disease who do have the exposure. Box C represents individuals who do have the disease and no exposure, and Box D represents individuals with no disease and no exposure.
There are many uses of the 2x2 table. They include calculating the risk of disease for a population with a risk factor, risk ratio, and attributable risk. We will explain each of these with an example to explain how to use the 2x2 table to solve each problem.
To calculate the risk of disease, which is also known as positive predictive value and negative predictive value, for a given population and a risk factor, you can use these formulas. To determine the risk of disease for an exposed group, divide the value A by the sum of A and B. This is easy to remember because you are only using values from the top row. To calculate the risk of disease for a given population without the risk factor, simply use a similar equation but use the bottom row instead. You will use value C divided by C plus D. This is also easy to remember because you are only using values from the bottom row.
The risk ratio is used to correlate the risk of disease for both the exposed and unexposed groups. For example, using the risk ratio allows you to come to conclusions such as females are almost 2 times more likely to get Alzheimer's than males. It can be calculated using the equation A over A plus B divided by C over C plus D. Dividing these values will give you a result that will fall into one of 3 categories: equal to 1, greater than 1, or less than 1. If the risk ratio is equal to 1, then there is no increased risk of exposure for the disease given the risk factor. If the risk ratio is greater than 1, then exposure to the risk factor increases the risk for the disease. If the risk ratio is less than 1, then there is a decreased risk for the disease. We will show you some simple examples of each of these to better understand how to use the 2x2 table for these calculations. Suppose in a hypothetical study that 10% of male subjects get Alzheimer's disease, and that 10% of females get Alzheimer's. In this case, the risk ratio would be equal to 1. In our second example, assume that 20% of females get Alzheimer's, where 10% of males get Alzheimer's. In this case, the risk ratio would be 2, meaning that females are twice as likely to develop Alzheimer's as males. Finally, suppose that 10% of females get Alzheimer's, while 20% of males get Alzheimer's. In this case, the risk ratio would be 0.5, and therefore females would be half as likely, or have 50% less chance of getting Alzheimer's than males. Now let's try a few more detailed examples. Take this population of 22 individuals. We will calculate the relative risk of developing diabetes in relation to maintaining a healthy diet and regular exercise. 12 of these individuals wake up and go to the gym 5 days a week. 2 of these exercisers have diabetes. They represent the individuals in box A who do have the disease and the exposure. The remaining 10 go in box B, the individuals who do not have the disease but do have the exposure. Of the remaining 10 that do not exercise regularly, 7 of them do have diabetes, so they will go in box C. The remaining 3 do not have the disease and do not have the exposure, so they go in box D. Then add the totals. The total number of people with the exposure is 12. This is boxes A plus B. Without the exposure is 10, boxes C plus D. The total number of people with diabetes is 9, boxes A plus C. And the total number of people without diabetes is 13, boxes B plus D. Plug in the values from boxes A through D into the relative risk equation and calculate. In this case, relative risk would be 2 divided by 12 divided by 7 divided by 10, which equals 0.24. Therefore, your risk of developing diabetes is decreased by 24% by maintaining regular exercise. Now, here's another example. We'll use this population of 17 individuals to determine the risk of female sex in developing Alzheimer's disease. Of the 6 females in this population, 1 of them has Alzheimer's. Of the 11 males in this population, 1 has Alzheimer's. Now, pause the video and use a 2x2 table to calculate the relative risk of developing Alzheimer's with the exposure of female sex. When you have the answer, play it again to see how we solved it. Relative risk equals 1 divided by 6 over 1 divided by 11, which equals 1.85. So the female sex has an 85% higher risk of developing Alzheimer's than the male sex.
We will now move forward to calculating attributable risk. This value is easy to calculate as long as you have calculated the risk of disease for both populations. For example, let's say that males have a 1% chance of Alzheimer's and females have a 10% chance of Alzheimer's. To find the attributable risk, simply subtract the risk of disease for both groups. In this case, the attributable risk is 9% for females. Here again is the 2x2 table. Notice how you simply subtract the risk of disease for the top row minus the risk of disease for the bottom row. Our last use for calculating risk is the attributable risk percentage, which can be calculated using the risk ratio. This value helps a researcher determine the percentage of a disease that is explained by a certain risk factor. Let's assume here that the risk ratio, as seen before in our second example of risk ratio, that females are twice as likely or 100% more likely to get Alzheimer's. To find the attributable risk percentage, subtract 1 from 2 and divide it by the original risk ratio of 2. This will give an attributable risk percentage of 0.5, or 50% of Alzheimer's that is caused by being female.
Thanks for watching our video using a 2x2 table to calculate risk of disease, risk ratio, attributable risk, and attributable risk percentage. We hope you enjoyed. When you see risk questions on your board exam, just remember, it doesn't have to be risky business. Just use your 2x2 table.